So let's tackle a really fascinating question today. How can we redefine our most basic particles? Electrons, protons, and neutrons. Not as these tiny microscopic dots, but as geometric states of spacetime itself. Yeah, this is a journey into a totally different way of seeing reality.
I mean, what if they were just vibrations? Stable, oscillating patterns happening in some deeper geometric substrate. Well, that's the core idea behind a theoretical model called the methane meta-universe, or MMU for short. And if it's right, it changes pretty much everything.
So, first thing you have to do is just forget empty space. In this model, the universe is built from these fundamental geometric units called cells, these cool dual-tetrahedral shapes, all connected together in a massive lattice. This lattice, this is the fabric of reality.
All right, so to understand how particles just sort of emerge from this structure, we first need to get a handle on the rules of the game. How do these cells actually behave?
You see, each cell isn't just a static little shape. It has 3 hidden internal ways that it can move or deform. Think of them as its internal response channels. You've got W2, which lines up with electric properties. Then there's W3, a kind of twisting or torsional mode that's related to magnetism. And finally, W4, which is all about a change in volume, and that's tied to gravity.
Now, this brings us to an absolutely crucial point. We don't actually perceive these hidden W2, W3, and W4 modes directly. Our entire observable reality, everything we can possibly measure, is just a projection of all this complex internal motion onto a single observable axis, which is called W1. It's kind of like seeing the shadow of a really complex 3D object on a 2D wall. The shadow gives you clues for sure, but the real action is happening in a dimension you can't directly see.
Okay, so with those rules in place, we can actually start building something. Let's begin with the simplest particle we know, the electron.
Right, if everything is just a state of this space-time lattice, then what specific configuration creates the particle that we call an electron?
The answer is just beautifully simple. An electron is a single cell caught in a stable, repeating internal oscillation. It's not a point particle at all. It's a localized, vibrating piece of spacetime itself. And its stability comes from something called phase closure, which just means the vibrational cycle repeats on itself perfectly, like a flawless musical note that's held indefinitely.
So get this, all the properties we associate with an electron just emerge directly from this single cell's oscillation. Its electric charge, that's the projection of its W2 electric mode. Its intrinsic spin, that comes from the projection of the W3 torsional or twisting mode. And its mass, that's set by the projection of the W4 volumetric mode. It's all right there, baked into the geometry of the vibration.
Okay, so that's the electron. Simple enough, right? Let's move on to the proton and see how this whole thing starts to build in complexity. We all know a proton is way, way more massive than an electron. So how does the MMU account for this huge difference without just saying, well, it's a different fundamental particle, duh?
This is where the model's elegance really starts to shine. The proton isn't a single cell. It's a stable composite structure formed by 3 cells that are phase-locked together in a very specific chiral configuration. And chiral just means it has a distinct handedness, like your left and right hands. This forms a much more complex, interconnected geometric shape.
So all of the proton's properties just arise from this collective geometry. Its much greater mass, that comes from a higher collective stiffness. Think of it like a very tightly wound spring versus a loose one. It contains a lot more energy, which projects as more mass. Its spin isn't from some tiny subparticles. It's from the complex, coupled internal dance of these 3 cells, all oscillating in perfect unison.
So we have the electron as 1 cell, the proton as a 3-cell composite. All right, now what about the neutron?
Is it a 2-cell structure? A 4-cell? Well, the answer in the MMU is actually way more interesting. It's not a new fundamental structure at all. See, in the MMU, the neutron is a dynamically stabilized state. It's a special configuration that gets created when an electron and a proton lock together. And this special union only happens under a very specific condition known as the electrogravitational fixed point.
This fixed point happens when the stiffness of the electric mode, let's call it K2, becomes exactly equal to the stiffness of the volumetric or gravitational mode, K4. When an electron and proton are coupled and this perfect balance is met, something really fascinating happens. The electron's torsional mode, its W3, gets suppressed. It's basically canceled out in the partnership. But, and this is crucial, the proton's torsional mode survives, which is why the resulting neutron still has spin.
And this configuration neatly explains all of the neutron's properties. So why is it electrically neutral? Because in this locked state, the outward radial projections from the electrons and protons' electric modes just cancel each other out. And why is it slightly more massive than a proton? Because the coupled state causes an enhanced deformation in that volumetric channel, the W4 mode, which projects as just a little bit more mass.
Okay, so let's just step back for a second and look at the big picture this paints. It's a fundamentally different way of thinking about what a particle even is.
The standard view, right, it treats particles as fundamental, point-like objects that are just given their properties like charge and spin, no questions asked. But the MMU view says, no, those particles aren't the fundamental things themselves. They are stable, geometric states. They are vibrations of one single underlying space-time fabric. The properties aren't just built in. They emerge from the geometry of the vibration.
So, to quickly summarize what we've covered in this explainer, in the MMU, an electron is the simplest possible excitation, a single vibrating cell. A proton is a more complex, stable composite of 3 cells locked together. And a neutron isn't fundamental at all, but a special phase-locked configuration of an electron and a proton.
And that right there is the powerful takeaway. Instead of a zoo of different fundamental particles, the MMU offers this really unifying vision. 3 familiar but very different particles, all arising from the vibrations of a single, common, geometric structure. It shifts the fundamental question of physics from what are things made of to what are the stable patterns that reality can form.